and welcome everybody to our track on SoC design. This track, like Linley said, is near and dear to my heart because wherever you go, any company you see, you're going to have SoC design as a final product. Today we have three great speakers to discuss their company's unique approach to SoC design. And on a personal note, these three speakers is the crossover episode that you kind of always wanted. We have SiFive, ARM, and RTOS IP all in one talk. So without any further ado, I'd like to introduce Yunsup Lee from SiFive. Yunsup got his PhD from the esteemed UC Berkeley, where he actually co-designed the RISC-V ISA. He currently serves as the Chief Technology Officer, and he is the co-founder of SiFive. So he's here today to discuss SiFive and its increasing configurability on IP for developing Linux PCs. Yunsup, whenever you're ready, you can share your screen and I can see you. So take it away.
Thank you very much for the kind introduction. I'm Yunsup Lee. I'm really excited here today to talk about creating a RISC-V PC ecosystem for Linux application development. So bringing a new ISA to life is a lot of work. I've been at it personally for the past 10 years, so I can personally attest to that. By the way, 2020 is the 10th year anniversary of RISC-V, so we're just kind of turning into a teenage now. So just to kind of summarize what I've learned, what's important that was along the journey. To summarize that in 3 words, it's software, ecosystem, and community. So at SiFive, at the very beginning from 2015, we took that very, very seriously. And in order to build a vibrant software ecosystem and a community, we doubled down on building software development boards from day one. So the first product that we've brought to market was HiFive 1 for embedded development. And soon after, we revised HiFive 1 to add Wi-Fi and Bluetooth, and we've announced HiFive 1 Rev-B. And in parallel, we also built HiFive Unleashed for Linux application development. The HiFive Unleashed board was able to connect to a HiFive Unleashed expansion board, a collaboration with Microchip, to kind of provide bigger expansion capabilities so that you can go attach your own accelerators, and it supported a bunch of IOs like PCIe and such. So we built a lot of domain-specific computers using this. The one that you're seeing right here is connecting HiFive Unleashed with the open source NVDLA to give it a boost on AI ML application capabilities. So today we're here to talk about the next generation RISC-V Linux application development platform. So before I do that, I just kind of wanted to show you the list of applications and Linux distros that work for RISC-V today. So just to kind of name a few. So there's Coreboot, U-Boot, the UEFI, the Tiana Core. All works for RISC-V. It's been all verified on the previous HiFive Unleashed development board. We have the Debian, Fedora, Ubuntu, Gentoo, SUSE, FreeBSD, NetBSD, Linux distros, all working for RISC-V and have RISC-V support, and have been working on the HiFive Unleashed board that we had before. So moving on to the embedded RTOS and debugging tools and IDE part. So we have a very vibrant ecosystem here as well, both in the open source and on the commercial sector. So on the open source side, we have FreeRTOS, RTEMS, Zephyr, Riot support. On the commercial ecosystem side, we have great RISC-V support from IAR, Seger, Lauterbach, Wind River, and additional companies. So we've been hearing a lot of your feedback based on our previous development board platforms and products. And consistently, what we've been hearing from the developers is that they really like the Linux-capable development platform. We haven't made enough of HiFive Unleashed development boards available for the market. They would like more advanced features like better I/O support, better expansion capabilities, all coming in an industry standard form factor. And obviously everyone wants software to run out of the box as well. And we later on figured that a lot of our SiFive core IP customers are evaluating our IPs based on the board. So we took all this feedback from our developers and the community, and we built a new product. And we're so excited to announce our new product today. So here it is. Ta-da! This is the HiFive Unmatched development board. This is the world's fastest native RISC-V development platform. So what's inside the development platform? Let's go take a look. Okay, so at the heart of the HiFive Unmatched board, there's the SiFive FU740 processor. There's 8 gigabytes of DDR4 memory. There's 32 megabytes by flash. There's the micro SD card for boot media. Here's the 4 USB 3.2 Gen 1 ports, a gigabit Ethernet port, a micro USB console connection, and there is a by 16 PCI Gen 3 expansion slot backed by 8 lanes. There's also a M.2 slot for your NVMe drive here, and also an M.2 E key so that you can put your Wi-Fi and Bluetooth connectivity right here. And this everything comes in a mini ITX PC form factor with a 24-pin power supply connector, ATX power supply connector. Okay, diving into the board a little bit more on the FU740 SOC, what's inside the SOC. So at the heart of the FU740 SOC, there's 5 cores, 4 U74 cores, and 1 S7 core, the embedded core, all backed by a coherent 2 megabyte L2 cache, which is backed by DDR4 memory. And on the side, there is a PCI Gen 3 by 8 controller, gigabit Ethernet, and a bunch of other peripherals on the same chip. So I'm going to dive a little bit deeper into the RISC-V cores that are on the SoC. So it's the SiFive 7 series core. It's an 8-stage dual issue superscalar RISC-V core. You can pick and choose the RISC-V ISA string, so you can drop some of the standard extensions to make it more efficient for application. And there's a lot more optionality that you can select. All comes through SiFive Core Designer from our website. So if you're interested, you can go check out our website. So the 7 series core, you can have both the L1 instruction cache with ECC and the instruction tightly integrated memory, or ITIM, with ECC support. You can select between the L1 data cache and the DTIM, and optionally, you can enable the data local store for more predictable access to critical data of your application. And PNP support is there for security. You can put 1 to 8 cores together, coherently backed by a shared L2 cache. Also comes with pre-integrated Shield security and pre-integrated SiFive Insight Advanced Trace and Debug. And optionally, you can enable the SiFive hardware cryptographic accelerator IP for building your own core complex. So you can not only build homogeneous core complexes, you can also build heterogeneous mix and match core complexes. So in this example, we have mix and match an S2 core, a small embedded core with an S7 core, with 3 U74 cores, all in the same core complex subsystem, all backed by a coherent L2 cache, and all your favorite security, trace debug, HCA options are all enabled in the mix and match core complex IP. And you can connect the core complex IP with PCIe controllers backed by DRAM, peripherals, non-cacheable SRAM, or cache coherent SRAM as well. So what's good about this subsystem? Well, you can mix and match the real-time and application processing. You can run the Linux applications on the U cores while you're running your real-time embedded routines on the S cores, all coherently in the same memory subsystem. And even the application processors here have features to enable deterministic processing. If you like to turn some of the application processors towards your embedded computation, So as I told you before, there's the data local storage and the ITIM or the DTIM option that you can put for the application processors. There's support for low latency local interrupts, and you can waylock some of your L2 cache content so that you can have predictable access to content in the L2 cache. So we also continuously make our IP better. So this year we had a 20G1 update for the 7 series, where we boosted the Spec 2 K6 performance by 11% compared to our previous release. We added improved streaming performance to get this performance boost while reducing power by 25%. So we're really excited about this update. So if you work with SiFive, you will continuously get these type of updates delivered through SiFive Core Designer. Okay, kind of moving on to the software side of things. So first and foremost, the HiFive Unmatched product and Unleashed product comes with Freedom U SDK support based on Yocto Open Embedded. So using the Freedom U SDK, you can build your own custom Linux distribution, and also comes with U-boot, OpenSVI, all packaged together and open source. You can download it. It's available on GitHub at this link over here. All this Freedom U SDK works on the HiFive Unleashed board, as well as the newly upcoming HiFive Unmatched board. Okay, moving on to Debian support here. So Debian currently builds about 95% packages for RISC-V. This is a very important milestone in becoming a normal architecture. So at the last RISC-V summit back in December 2019, Carlos had showed Docker and Kubernetes all working on Debian distro on RISC-V, especially on the SiFive HiFive Unleashed board, as you can see down here. Okay, last but not least, here's the Fedora distribution running on RISC-V. So the support has started back, starting from 2018. So the most recent news on Fedora distro is that EFI support for RISC-V has landed in Linux and has been working on HiFive Unleashed. And therefore, the same support will be running on HiFive Unmatched as well, since both are compatible. So this is the Genome desktop running on RISC-V HiFive Unleashed on the Fedora distro right here. So, okay, it's a PC product. So I would love to show you a demo of all this running. So what you're about to see is a Linux distro booting on XFCE Windows Manager desktop environment. I'll show you the web browser functionality and some of the native compilation of a benchmark and GPU accelerated video playback. These videos will be posted on YouTube soon after this talk. So let's dive right into it. So this is the case, PC case, with a HiFive Unmatched mini ITX board mounted to it. It looks just like a PC to me, although the fan is a lot smaller than what I used to see, which is a good thing. There's the GPU card that you're seeing. So here's the XFCE desktop. So just like a real PC, you go connect to Wi-Fi to really use it. To show that it's a real RISC-V PC, here you go, cat. It's proc CPU info. You see it's a real RISC-V with 4 cores, 64, 32 kilobyte IND cache, 2 GB L2 cache, and here's the enumeration on the PCIe bus. As you can see, all the devices are coming up. So let's browse the web and go to sifive.com. Go to the board section where any related HiFive Unmatched information will be coming to the website. So if you're more interested in learning about the board, you can come to the SiFive website. There will be updates posted to the website soon after the talk. So there will be so this is the Unleashed Getting Started guide. There will be a similar Getting Started guide posted on the website around HiFive Unmatched development board as well. Okay, so moving on to showing an actual compilation. So this is more of a live video right here. sped up. So you can see the HiFive Unmatched board sitting in the PC case there. It's connected to the previous HiFive Unleashed board right here. So currently what we're doing is just like what you do on a PC, you compile your benchmark on the PC natively, RISC-V, it's the StressNG benchmark that we're compiling. We just downloaded the StressNG benchmark to the HiFive Unleashed board via the Ethernet port, and you can kind of see that it works on both boards. So it's a real native compilation environment for professional developers. So now moving on to
open source CPU architecture,
showing some videos, accelerated video playbacks using GPU. This is one of the Linus Tech Tip clips that was released just before. So we're just showing that on the HiFive Unmatched board right here. So it's being played back on this board, with accelerated GPU and USB device, sound device support as well. So hope you're excited about the HiFive Unmatched RISC-V PC, and if you are, you should consider building your own Unmatched RISC-V PC. So this will be available this quarter in Q4. The suggested retail price is going to be $665, a lot more cost efficient compared to the previous generation HiFive Unleashed board. So what do you get? In the HiFive Unmatched product, you'll get the mini ITX board and a bunch of goodies that come with it. So if you can't wait until, and this will be available on the Mauser distribution site. So if you can't wait, and if you'd like to put your pre-order in, you can go email sales@sifive.com today so that you can kind of get yours in the queue. Okay, with that, that's the end of my talk. Thank you very much, and I'd be happy to answer any questions.
So what is the clock speed that you're seeing on the for this CPU?
It's similar or higher than the previous HiFive Unleashed, which we shipped the product at about 1.4 gigahertz, but for people who were adventurous enough, they would move it up to 1.5 gigahertz. So this product would support the same clock speed or higher than the HiFive Unleashed board.
And so is overclocking allowed for your processor if someone were to take that adventurous route?
Well, I mean, it's a development board, but I wouldn't quite recommend it.
Okay.
No, I can't stop people, but I wouldn't recommend it.
That's fair. That's fair.
But I mean, as all PC products go, there's always some people who would post some cool videos see how fast I could get my clock speed up. But
So can you discuss a little bit more about the security features that are embedded into the RISC-V board?
Sure. So we have the SiFive Shield product, and I think we've also presented the SiFive WorldGuard kind of security feature or product at the Linley conference, the most recent one, or maybe it was in the fall. Yeah, it's all the memory related things can be tagged with a world ID and can be further filtered out throughout the SoC ecosystem. So there's filters and tags and all that throughout the entire kind of SoC you can go build. So it's actually, there's a socket that, there's some configuration that you can do to make a SiFive Shield WorldGuard look exactly kind of slot into your existing trust zone kind of SoC infrastructure as well. So it's pretty seamless there, and it just kind of interoperates pretty well.
Okay. Do you mind stop sharing your screen so we can see you a little bit better?
Oh, okay. Or I can make myself bigger.
Okay, that works for me. The second question is, with CXL starting to reach maturity, do you expect to be able to support that for future boards? Or is that kind of a ways out for you guys?
That's a very good question. Our core business is kind of selling RISC-V core IP, and we definitely have been talking to a lot of our partners who've been asking for the CXL support. And, if the customers really want that for their applications, we're there to solve our partners' problems. So yes, CXL is on the roadmap, and if you're more interested in talking with us about that, just please contact us through our website or sales@sifive.com. More than happy to talk about that. And kind of the development platform support of all of our features all trickle in. So whatever we say is going to be on the core IP probably will be showing up on our future development platforms.
Okay. And then so recently you guys released your vector processing unit.
Right.
Would we be seeing variation of this that features the vector processing unit?
That's a very fair question. I can't speak in concrete terms, but I think people really want to build software ecosystems around RISC-V vectors. So, we basically respond to solving our partners' problems. So perhaps,
perhaps, that's
yes,
fair.
perhaps would be my, strongest answer. But I personally would love to see such support myself.
Can you discuss a little bit more about the state of the software ecosystem in RISC-V? And what are you guys seeing? What are some common applications that have already gotten a RISC-V optimization or whatever it may be?
Yeah, that's a really good question. I think probably embedded is everybody accepts that there's a great software ecosystem rivaling, some of the other possible solutions out there. And people have been integrating a lot of RISC-V, SiFive, of course, in particular, into their application SOCs. There's great support on debug, trace tools, IDEs, as I told you before. Making myself smaller so that you can see. So there's great support for commercial tools, software ecosystem partners, IR, Sager, Lauterbach, Wind River, Migrium, Imperis, Ashling, and the list is just growing over here. So people kind of really enjoy now using this. They feel like it's seamless, and it kind of all works out of the box seamlessly. So that's kind of state of the embedded software ecosystem. It really works well. There's a lot of people that use RISC-V. For the application Linux software ecosystem, this is a pretty good set of support out of the box here for RISC-V. And we're really excited with the HiFive Unmatched board coming out that, and we're making the board available, building it in a lot more quantities based on feedback we've been getting. So there'll be a lot more boards out there so that people will be able to kind of work on their favorite software ecosystem bit. And we just see the HiFive Unmatched board will accelerate even further the RISC-V Linux and application software ecosystem.
So again, a little bit more on the software side, do you have any ML for AI benchmarks also that you could discuss on how this board is running to kind of show maybe training or inference data, how your board performs?
I don't have a number readily available right now, but those numbers will soon be coming out. And I mean, the board will be soon coming out as well. So you probably will be able to run it on the board yourself as well.
Okay, sounds good. And then do you guys have any virtualization support that we could look forward to? On the software stack?
Right. So on the HiFive Unmatched board, there is you're able to run the emulated version of it. So of the hypervisor spec that is currently being developed with RISC-V International. The hardware acceleration support for the virtualization things will be soon coming.
Okay, that works for me. And then do you have what are some general purpose PC applications we currently can expect or that is supported by RISC-V?
I think all the open source side of things, definitely it's coming along and has come along. I can't really predict what's going to happen on the commercial application side of the things. But I mean, there's a lot that's currently being discussed. And I think soon you'll see a lot more interesting things coming up, is I guess about what I can say.
So when you do the mix and match method for developing SoCs for your PC, how are you making sure that data is secured for inter-core connections, and how are you ensuring overall SoC security?
Right.
Because, yeah.
Yeah, no, that's a really great question. So the cores itself have physical memory protection, which is kind of governed by the M mode software. So we believe that's already a very good kind of answer to that, to kind of make sure that cores will not be stomping on each other's. But in order to kind of elevate the physical separation of all these cores, that's where the SiFive Shield Core Guard kind of product comes in, to physically tag all the things that are coming out of the cores, as well as other, bus mastering devices, to make sure that the physical separation is guaranteed by the hardware and the SoC.
Okay. And then this one has been drilling a hole in my mind. What's the graphics card support look like? Because you were running a pretty nice looking Radeon there, but so what are we talking about here?
Yeah, making myself smaller again. Yeah, so the graphics card, you can slot a 8x16 graphics card in there, and since it's running Linux and whatever great driver support we have in Linux today, we've been finding that it works pretty well on RISC-V. So we've been, kind of working on a couple of graphics cards because we just kind of got that working out of the box. But I can't really tell exactly how many graphics cards we'll all be supporting. But I mean, there's PCI Gen 3x8 lane physical lanes going to the graphics card, so it's a pretty good I/O link there between the CPU and the graphics. And we've been really pleased on kind of the smoothness and just the look and feel. I had to train myself to not say it's like a PC, because it is a PC now. As you can see, it's not like a PC, it's a real PC. You can just put it on your desk, put it on a case like that, put a just kind of throw on your graphics card, plug in all your favorite USB devices, and the Linux driver support has been working.
Yeah, you've just missing some RGB lights and you can throw it on Reddit.
Oh, absolutely, it will work like that as well.
So we've been discussing a lot of this in a lot of RISC-V and SiFive's work in terms of the PC and Linux scope. Are you guys going to move Android or your course to support Android in the future?
That's an excellent question.
Android and even Google to extended Chrome OS and some of the other
that's an excellent question. I can tell you, somebody's calling me. I can't pick up the phone. Perhaps asking for Android support, actually. Yeah, I mean, the phone has been like this for a while on Android.
It's not a bad problem to have.
Exactly. But, again, we're here to really help solve our partners' problems. And many of our partners are asking, when is Android kind of going to come show up? So, I mean, you can't really speak today, but there's a big portion of Android that is open source, and I've already been seeing some open source efforts to port Android to RISC-V. But I can tell you that there's a lot of partners who are interested in Android today. So we're here to serve our partners. So that's, I guess, about all I can say.
Hey, you guys have the best customer service policy. So one last question before we start to run out of time. The coherent fabric that you guys use,
Yes.
Is it an in-house IP, or do you guys source it from an external vendor?
That's a great question. So it's all based on TiLink, which is a free and open standard that we've been put together. So the spec is all online. You can go take a look at it. So it is based on our internal technology, but it's based on a free and open standard that we published to connect all the things together, including our cores to the high-speed I/O subsystems and things like that.
Okay, I think we're about there for time.
All right, thank you very much.